In this video I will show how to make schools of fish using Niagara particles. First is this generic group of fish that will disperse over time to populate an area. You can see there are different types of fish here and it is all done in a single particle. The fish also wave, which is done using materials. You can use any mesh you want to create any fishes, although this is more geared towards smaller fish as collision isn't as big of an issue. Second is the circular or vortex movement for the school. In this the fish will move around a central point, which is sometimes common. The radius has been shortened for this map, but it can easily be increased. The number of fish for any particle can also be changed very easily. I also show how to make these smaller fish groups. Here you can see a smaller number of clownfish swimming back and forth through the skull eye. This second smaller group is of crucian carpfish. The particles will also collide with objects. Each particle is highly customizable, so you can make any effect you want. The default particle can have up to 3 different fish, although this can be decreased or increased. The spawn count and spawn area is easily changeable. The color multiplier can be randomized so the fish don't all look identical. The minimum and maximum size is changeable as well for more variation. The speed can also be increased by reducing the drag and vice versa. The fish will also either move away or attract towards the player based on this parameter here, with the strength being changeable. The Vortex template comes with the same parameters. The spawn range can be increased if you want a larger circle of them. There are also settings for the Vortex. Force amount will control the strength of the Vortex movement, with pull making them be pulled towards the center. Vortex axis min and max can be used to set the direction the fish swim around the center. This can make it more random if you want. Here is the smaller fish group. This is mainly for a single type, so there is only one variable for the mesh, which can be changed for different types of fish. If you purchase the project files, you will get 6 extra exclusive examples, starting with this pufferfish. These will actually expand and contract like pufferfish do, although it just controls the scale. Next is jellyfish. These will mostly stay in place and only move up and down in a bobbing movement. These are Seahorses. These ones will jitter around like real Seahorses. Next is a group of turtles which will swim around. Only the fins will wave around for the models, while the head and shell do not. Next is eels. These will wave much more, so it looks a bit like a snake slithering. Finally are these crabs. These will try to stay on the surface as much as possible. The crabs are not perfect, however, as I think Niagara isn't the best way to do them. Here is how the scene looks populated with the many types of fish and with the submarine and level design, including the ambient particle made in a previous video. The swimming and submarine shown in this video are from previous tutorials I made in the water series, but is not required to follow along for this video. For the models I will use these 3 from Sketchfab made by the users shown. You can use any. I scaled them in Blender, then imported them in Engine. You can see they all face the same direction. First we will make the material with the waving feature. Since we want to use any fish, we need to make the textures parameters so they can be changed. This is for diffuse. Multiply it by RGB from particle color so we can add the multiplier in Niagara. Then add a normal. I will make it a flat normal by default. Copy the code shown now for the wave function. It is based off a video by Coreb Games, which I will link in the description below. We transform the position to local space so it waves the same for any rotation. A sine wave is used here to alternate the wave from 1 to -1. Plug it into world position offset to deform the mesh. I did a setup for emissiveness. Now right-click the material and make an instance. I will set up the coral fish one first. Set the texture parameters. Now apply the material. You can see the fish waving. Open the instance and minimize or move it to another monitor to see the changes in real time. Adjust the wave parameters until it looks right. It should be subtle. These values worked for me. I updated the default values in the material so the other fish materials will have it. I quickly added a metallic roughness setup since these models have it. I then set up the materials for the other two fish off camera. You can adjust the wave parameters to your liking, and different fish can have different ones like I did with the eel example. Now we can make the Niagara particle. Right-click and make one. Select the hanging particulates template. Delete the sprite renderer at the bottom since we are using meshes, so add a mesh renderer. Set the default element to one of the fishes. You can see the fish spawned now. Now we will make it so we can have multiple fish in this one particle. In the user parameters, add a static mesh object variable. I will add 3 so this lets us have up to 3 fish, but you can add more if you want. Expand the element index. Where it says mesh parameter, click the drop down and set it as fish 1. Add 2 more elements or however many you need, and set the mesh parameters of them to the other ones, which are fish 2 and 3 for me. To randomize them based on our selection, add a set new or existing parameter directly module to the particle update. Click the add button and choose mesh index. Click the drop down and choose random range int, which is for integers. Make a new parameter of int32 type for the number of different fishes. By default it will be 0. You can see when I change the maximum to 1, it will add the second fish type. This is since arrays start from 0, so a value of 2 will use 3 fish and 3 will use 4 fish, etc. Drag the no of fish parameter onto the maximum value and it will set it to use that parameter. This lets us now easily change how many different fishes are used by this particle in the level editor. You can also click Edit Hierarchy and categorize the parameters if you want for better readability. Now select the emitter state module. Change the loop behavior to 1 since we want a set number of fish to exist throughout the particle. Delete the spawn rate module and replace it with a spawn burst instantaneous. This spawns a set number at the start as we want with the fish. I will make a parameter for the spawn count so it can be changed dynamically. You can see the number of fish changes now when I update this value. Next, go to Initialize Particle. Change the color mode to random range and make linear color parameters for the values. I will speed this part up as it is the same process. This will let us give each fish a random diffuse color multiplier between the selected values so it is randomized. You can see it working here. For mesh scale mode, set it to random uniform so it scales up proportionally in each axis. Again, make parameters for the min and maximum. It is best TP keep the difference to something low as the fish are of the same type so the size difference shouldn't be that substantial. I used 0.8 and 1.2. Now go to the shape location module. You can change the shape primitive if you want them to spawn in a different bounce shape, which I show for the vortex fish. Make the box size a vector parameter. This is the bounce size and the fish will randomly spawn within it. Now choose particle state. Uncheck kill particles when lifetime has elapsed so the fish will always remain. You can delete wind force, aerodynamic force, scale sprite size and scale color as they aren't needed. Add a vortex force module. Set the amount to something like 5000. You can make these parameters too if you want. Make the axis coordinate space world. The origin is simulation position by default. You can see the fish moving in a vortex, but it is way too fast. To reduce the speed, add a drag module. Make a parameter for the drag amount, which I will set to 15 by default. A higher value will make the fish slower. You can see the fish are much slower now. You will see the fish all face the same way however. To fix this, in the mesh renderer, set the facing mode to velocity so it faces the direction they are moving. If your fish is rotated like mine, it is due to the axis. To fix this, add an initial mesh orientation module in particle spawn and set the mode to none. The values are from 0 to 1 instead of 360, so to rotate it 90 degrees, set the z-axis to -0.25 or 0.25. We will now add a point force in particle update to move the fish randomly around. Set the strength to something like -2500 and the fall off to 1250. To make the fish not stay in the same area, we will update the force origin. Click the drop down and change it to convert position to vector. Set input position to add vector to position. The initial position should be the simulation position. For the vector, set it to multiply vector by float. Set the vector to a random range vector with the following values. Then for the float, set it to a sign by clicking the drop down. This will alternate the multiplier between -1 and 1, which is how the sign graph works. You can change the period value to your liking. I used 15. You can see the fish are more dispersed now. You can adjust any of the values used to fit your need. Next, add a point attraction force. This will make the movement even more random. You can copy the values I use. We will use a similar sign setup. Next, add a curl noise force module to make the movement less linear. You can trial and error with values, but these ones worked good for me. Now add a collision module. Change the radius calculation type to mesh since we are using meshes instead of sprites. If you scroll to the bottom, you will see the trace channel is world dynamic, so it will collide with them. I will now add the fish particle to the level for this underwater map I made, which uses the water plugin by Epic. You can see the fish will start up close together then disperse slowly but not too much. To make the fish interact with the player somewhat, add a line attraction force. Make a bool parameter to control whether it is attracted away or to the player. Make a float for the strength. If you want no interaction, you can set the strength to 0 or just skip this part. Set the strength to make custom float from bool with the bool parameter. For true, add an ABS float and set it to the strength. For false, set it to multiply float, with A being absolute of attraction strength. B should be -1. We need to get the player's world position now to check against. Make a Niagara parameter collection. Add a vector parameter called player position. You can rename it by right-clicking the name. In the particle, click on Parameters. Scroll down and click Add in Niagara Parameter Collection. I only have this one, so it will add by default, otherwise just select the one we made. Set the line start as the player position. The line end should be an add vector with 100 being added in Z to the player position. We need to set the player position value when the player moves. Open your character blueprint. In the movement input, get the Niagara parameter collection and set vector parameter. Make sure the name is exact with case sensitivity. The value will just be the actor location. Now the fish can move away or towards the player if close enough. You can adjust the strength easily if you want it to be weaker or stronger. I will now make it so the fish will not move out of the water. You can see here when I move the particle closer to the surface, the fish will start swimming out of the water since there is no collision to prevent this. One way to fix this is to add a cube covering the surface, which I found was the easiest. Add a cube to the level. Search for collision and change the preset to custom. Set all responses to ignore, then set world dynamic only to true. Set the object type to world dynamic since we used that trace channel in the collision module. Then set the X and Y scale so it covers the whole map or the area you want. Then uncheck all visibility settings so it is hidden in game. Now the fish will remain underwater, and if it tries to exit, the fish will just swim linearly along but below the surface. That is all for the main particle. You can see all the customizable parameters here, so you can adjust it however you need for any purpose. Also, if the collision is not working exactly, you can increase the Z scale of the cube and make sure to readjust the position to the surface. I will now show how to do the vortex/circular fish particle. I will get this fish model from Sketchfab by this user for it. Duplicate the original fish school particle since we will modify it. I will set the default fish mesh to the new one. First change the shape location's shape to cylinder. We can still use the same box extent parameter. Drag it into height. The Z channel will be used for height. For the radius we can use the X or Y. It works. For the Vortex inputs I will make parameters to control it. These default values looked good for me. Pull amount is used to stop the vortex from growing without stopping. For the axis, make it a random range vector. Randomizing this will make the fish swim vertically randomly as well, making it look a bit more natural. Delete point force, point attraction force and line attraction force. Reduce the curl noise force too. That is all. I made the vortex axis parameters too. It has the same parameters, so you can add multiple fish here if you want to. Here is the particle in game while in a submarine. Finally is the small fish group particle. I will get this clownfish and crucian carp model from Sketchfab by the users shown. This is really similar to the default one, but I will make it a separate particle anyway so it is easier to add. Duplicate the original. This is more for a single fish type, so I will remove the mesh index code and parameters except one. Also I will reduce the spawn count and range by default. I will make it attract to the player too. First reduce the vortex force amount to something like 500. I will adjust the point force and point attraction force, which you can copy the same values for if you want. Finally just adjust the curl noise force so there isn't as much. That is all for the small fish group. Again, you can very easily use any fish model you want and change it per particle using the parameter. All the fishes will move relative to their particle settings, so if you move the particle in the world, the fish will move towards it, which you can use to create more advanced fish movement. This will have to be done in code, as a world position will need to be found to move to. Also, as you can see, the collision works in this map too, as the fish are colliding with the landscape floor. That is all for this video. If you enjoyed, like and subscribe for more content. You can purchase this project from Gumroad using the link in the description if you want. The project files will include 6 exclusive particle examples, which are Pufferfish, Jellyfish, Seahorses, Turtles, Eels, and Crabs. It will not include the maps, swimming or submarines shown in this video, however, so keep that in mind. Thanks for watching.